bet. All right. Well, welcome to Intro to Routing. I'm going to cover 2 chapters tonight. Now, I will tell you, these are not going to match up with your book because your book starts in the second half of this semester. Like I said, we're going to go zip through the networking basics. We're going to cover them a little bit. And then I'm going to show you a little bit about packet tracers so that you can do your first couple packet tracers and get them turned in. Okay? How many of y'all have even attempted or tried to play with them a little bit? I know a couple people have got them in. It's pretty easy. Okay? I'll show you packet tracer. And as we get further along, I want to spend a little bit more time. I'd like to get through this networking, these 11 PowerPoints for networking, in probably the next 3 weeks. Focus a complete week on subnetting. You'll take your test. That'll be 5 weeks. And then we push through. Guess what? This is Monday night. Next week, there is no class. Because it's Labor Day. Don't ask me why 2 weeks into the semester we're already taking a holiday. This semester has been stressful enough for me, I'll probably deserve it. But I don't come in until 5 o'clock on Tuesday, so it'll be a 5-day weekend for me. I won't know what to do with myself. I'll be coming up here probably doing grading and all sorts of other stuff. But anyway, let's get through these real quick. These PowerPoints are not going to take me that long to get through. So if you can't see, move to where you can see. If you can't see there, get some glasses. Ha ha ha, pun pun pun. Come on, come on, come on. Just choose your chair. Tommy, that's your chair right there. Sit down. All right. Introduction to routing. We're going to talk a little bit about networks in general. The first couple of these are really generic, really general. How does it affect you? What is networks? Things of that nature. We're going to talk about the key components of a data network, the challenges posed by converged networks. What is a converged network? It'll come back to y'all. Describe the characteristics of network architecture. We're going to talk about fault tolerance, scalability, quality of service, and security. We're going to talk a little bit about instant relay chats and wiki servers, what those are. I'm pretty sure y'all know what an IRC is, right? Internet Relay Chat. And I'm pretty sure you know what a wiki server is if you've been paying any attention to the news about WikiLeaks, right? How do networks improve our lives? Well, it makes us all interconnected, right? Can you go anywhere now without being connected? The answer is no. Well, what is the purpose of an IM, or which we don't use anymore, right? How many of you use instant message? We use SMS, right? Called texting. Wikis, blogs, podcasting, collaboration tools, all those kind of got put together into social media, right? Instagram, Snapchat, Facebook, things of that nature, right? Well, instant messages was basically just a real-time peer-to-peer transaction where I could send messages back and forth. Weblogs, basically, it's a thread, if you really will, and a history of a thread so people can go read it. Podcasting, that's kind of what I'm doing. That's the original term. Basically, I'm just doing audio recording so that you can come back and hear my lectures later. Well, how do they interfere with our lives? Anyone know? Anyone want to take a guess? How do networks impact our lives? Do what? They keep us connected. For example, I like to use the illustration of Walmart. The second something is scanned at Walmart, it is already sent to the distribution center saying, I need that exact item on my next shipment to restock my shelf. Now what happens if your credit card doesn't go through at the register? They still get the order. So that's why you get a lot of discounted items, right? Because all those cold food that you brought up there and your credit card doesn't go through, can they really put it back on the shelf? No, because it's been outside of that area for so long. I don't know anyone that wanted melted ice cream to be put back in the freezer, right? It kind of causes a sticky mess. But if you go to Walmart, that's probably what they do. What different ways can we use to communicate over a network? Well, y'all have heard of VoIP, right? Voice over IP. That means you can use your phone, like down in my office, this phone over here, It's connected through the network. It gets power over Ethernet that supplies the power to that phone. I can use scanners, tools like inventory scanners. You see those at Walmart and your bigger thread stores. You don't see PDAs very much anymore because you use them on your mobile phone. You go to Lowe's. What do they have? They have a phone directly connected in there with everything they need right in their palm of their hand. ATMs, desks, networks impact your daily lives in so many different arenas. Online entertainment. How many of you actually go and watch movies via YouTube rather than watching on TV? Exactly, right? It's cheaper. You're not paying the cable bill. You're just paying the internet bill. You have online chat groups, online travel. Now you have basically TVs in every seat on an airplane that does international flights. It's better than, you remember, how many of y'all have been on charter buses where they have like 4 in the entire cabin? And you're stretching, you're either doing this or you can barely see the one way up there, right? That's what's come on. And then you have Wi-Fi networks on airplanes so that you can actually interact that you need to, right? Well, the basic characteristic of communication is I talk, you listen, right? Not professor, student. I'm just saying you have those rules of engagement. Someone's going to be doing something, someone else can be doing something simultaneous. So if I'm chatting with you, do you have to stop communicating with me for me to send a message? Absolutely not. So it's made asynchronous travel, right? Or asynchronous communication activities. Well, what does data networking do for us? Well, it puts it all into perspective that everything is interconnected 24/7. Data is always there, i.e. Google, right? Or Bing or whatever other. Yeah. So how do we do these? Well, devices connect to the network, connects, and that network sends on the message, right? You can have telephone networks, you can have broadcast networks, you can have computer networks. What is a device? Well, that is your end piece of equipment, your phones, your computers, your satellites, okay? A physical piece of equipment, that is called a device. The medium, that is the physical connection from that device to the next device, okay? A Cat5 cable is a medium. It's what can traverse, okay? Messages, that's the information that travels on those mediums, right? And rules. We're familiar with the rules, right? Y'all have heard of 802.3s and 802.11s, all those standards. Those are rules that tell us how we can confine our and dictate traffic. What is a converged network? Simply put, it is one network that can have multiple types of data, video, voice, and data, all on the same line. That is a converged network. So, in reality, Rose State is a converged network. Why? Because we have video conferencing that we do, we have VoIP phones, and we traverse our network, right, with data. So we have a converged network here on campus. What is fault tolerance? Fault tolerance simply means if something is to go down, I have something that can replace it. I prevent a situation from happening. To get to the internet, I have 2 routers to go. I have 2 different ways to get into these 2 external routers to get to the internet. That is fault tolerance, or also called redundancy. Okay? Scalability. That just means how much room am I going to allow my network to grow without replenishing anything. So if I'm focusing on this network here in this room, and I say, well, this room has 16 computers in it. Well, 17 if you count this one. I may have 17 outlets on the wall. Did I make this room for scalable growth? No. If I put 100 ports on these walls, did I make this room for scalable growth? Yes. The rule of thumb is 33% of what you have. Okay? It's actually basically for every 8, it's the rule of 8.3 if you want to consider that. For every 8 devices, you want to have 3 free, so that you can fill up a 12-port switch with the one coming in to support all those lines. Does that make sense? Y'all with me? Do I need to draw it up? I'm going to draw it up anyway, just to show you. I have a 12-port switch. right? I think that's 8 ports. Anyway, if I'm using my 8, I have 3 for growth, and I have my WAN. Okay, does that make sense? Just picture it. For every 8 objects that you have connected to the switch, you want to have 3 open ports. Quality of service. What is quality of service? Exactly. Who are the worst people for quality of service? Phone companies. How many people have had drop calls? I can tell you there's probably 18 spots in my house where I lose signal. And one of them's laying on my bed because I'm not going to sit there and talk to you for an hour holding my phone. I'm going to lay it on the bed and I'll be laying there next to it talking to you. And then I may hear out of my ear, I don't know. But that is where I lose signal. No kidding. I have my bed in the wrong spot. Security. How are we going to implement security? What type of security devices are we going to have? We're going to have encryption. Y'all are all familiar with encryption, right? What does encryption do? It just changes the clear text message into an undecipherable language. Does that always work? No. WIP. You know? ACLs, access control lists. What is an ACL? It prevents certain ports, people, rules, roles from functioning without permissions. Then you have firewalls. They can turn off or turn on ports or types of services, TCP, HTTP, UDP, IP, whatever. Packet switching helps us improve the resiliency and fault tolerance of the network the network. Why? Packet switching lets you see the packet and decide which way is it going to go. It can give you a multitude of different ways to go. I guarantee you, you send out a packet to someone else in this room. One packet might get to Germany before it comes back into this room, and the other one may just go to the switch and come back in here. Okay? There's no telling which way it's going to go. That's what packet switching allows you to do. Hierarchical. What is a hierarchical standard? Your chain of command, right? We're all on that low level, right? We're on the access level. Common standards and protocols. What that does is it says, all right, all these local ISPs, they're tier 3, tier 2 are the stuff to get to it, and tier 1 are going to be your servers. Or, well, actually, tier 1 will be the servers at the ISP, and then to get to the home, you're actually in the tier 3 level. Common protocols allow you to connect and talk to each other. That would be like me talking to Christina. And if I say, hi, Christina, and she responds, hi, if we haven't established a common protocol that we both speak English, are we going to be able to communicate? If I start speaking in German to her, is she going to be able to communicate with me? I don't know. Maybe, maybe not. If she speaks German, she might be able to. She might know more German than I do. You know, der Hundeslus, Katz ist im Keller. They're not? See, I just changed on them. You know, so we didn't agree on the protocol here. You've got to agree on a specific standard or rules. For example, if I didn't give you a standard or a protocol, if I didn't give you that standard of a syllabus, how would you know what I'm going to grade you on or how I'm going to grade you, right? I could change it up at any point I want. Derek, I don't like you today, so I'm going to give you 100% of your grade is going to be a final. What would that do? As I've already told you, you're all going to fail your final, so what have I done? Essentially, I've just told him that he's going to fail the class. But then I may come over and say, Adriel, I like you a lot. I'm going to give you 100 on everything just for showing up. Okay, now, did I have a defined standard here? No. That would get me fired, wouldn't it? Okay, probably. It depends on if Adriel won't complain. Derek would, though, right? Factors that can affect the quality of service. Bandwidth. I can't stress enough. Bandwidth will affect your quality of service. If you're dialing up on a 56K modem versus a T1 line versus a 100 megabit cable internet, which one is going to have the best quality of service? The one that has the greatest throughput. Okay? And you can also have priority decisions can affect it. For example, I have low priority device, a web page, medium device, a financial transaction I'm trying to get in my bank. Usually those are going to be your HTTPS stuff. Then VoIP. VoIP will be a high priority. Why? Because it's by federal law that all phone service has to be given the highest priority for emergency purposes. Because that's the easiest way for you to communicate to the fire department. Can you send them an email? How many of you know the local email for your fire department? How many of you know the local texting number for your fire department? No. I wonder if you could text 911. It's a good question. I'll have to ask a friend of mine who's a 911 operator. I'd probably get in a lot of trouble for that, wouldn't you? All right. Quality service mechanisms. Remember, we're on a converged network, and all traffic is not alike. Thus, that means you've got to be cognizant of what type of traffic you're putting on what network and make sure you have the right equipment for that network at that time. Everyone pretty generalized stuff, right? Because you don't want this kind of thing to happen. How many of y'all have ever had someone hack your bank account? Stolen your credit. Yay, me. Brittany, you stole your own. She works at a bank, so she can steal her own. It's called embezzlement, right? Just kidding. All right, basic measures to secure data network. You want to authenticate the user, and you want to encrypt your data, right? I have a pretty good game that I like to throw out there for y'all to play with. It's called Cyber Protect. How many of y'all had me and had Cyber Protect? A lot of you, right? This approach comes in very handy. User authentication, data encryption. If I'm trying to access your network illegally, what is going to be the first thing that's going to stop me? Access controls, right? Intrusion detection, and user authentication. You start by protecting the data that's in the center of the onion. Y'all have heard of defense in depth, right? You have to start from that center and work your way out by putting as many layers or as many security objects between you, the data, and the intruder. Any questions on that? I didn't make you buy that book. Aren't you nice? All right. Now let's talk a little bit about network fundamentals. Network fundamentals. There are three primary sources or elements to a communication. You have the message source, the message destination, and the channel, right? Y'all remember that from speech. I'm the source, y'all are the destination, and the channel is my voice being spread amongst the classroom, correct? Right? Y'all all remember that. Shake your heads. It's not time to go to sleep yet. Well, in the same type of information, let's define a network. We just talked about it. A converged network carries multitude of these type of communication environments, right? So how do you encode it and send it across the network? Well, how are they communicated? You can do segmentation or multiplexing. If I want to segment a communication, that means I'm going to specifically put it to one person. Okay? Lee, I'm talking directly to you. Right? Or James, I'm talking directly to you. Or, I don't know. That's segmentation. Okay? Multiplexing. I'm sending it to Whitney, and to Brittany, and to Derek, and to Christina, and to Adriel. I'm not flooding my network because I'm not sending it to everyone in the classroom, right? I'm only sending to specified source. That's called multiplexing. Same idea. I'll use that concept when we start talking about unicast, multicast, and broadcast. Network components are broken into two different types of things. They have hardware and software, just like a computer. Isn't that really strange, right? You have to learn a lot of new information. And you're going to have a client and server network, right? Or you're going to have peer-to-peer. The role of devices. They can be a client, they can be a server, or they can be both. In the instance they're both, that's a peer-to-peer network, right? If you're just a client and you're just connecting to just a server, you're on a client-server network. How many of y'all have had network administration? Or a basic operating system class where you understand how to communicate with the difference between peer-to-peer and client-server, right? All right. But how does the data get there? It's got to go through what we call an intermediary device. That intermediary device is what we call routers and switches. Okay? All that does is provide connectivity to ensure data flows through the network or across networks to get to point A, from point A to point B. I'm not trying to bore you to death or put you to sleep. Am I pretty monotone tonight? Am I good? Okay. Just making sure. I don't want to. If I need to jump up and down, do jumping jacks or something to get your attention, I'll do something. If I have to tell you. Do what?
You need a woohoo from the back?
I need someone to go, woo! Oh, okay. That's going to be loud on the recording, by the way. All right, network structure can be on, it can be on coaxial cable, it can be wireless, it can be fiber optic, it can be copper. Network media, copper cables, like I said, it can be on coaxial, it can be on RtgLs, RJ45s. That's what we call twisted pair usually for your UTP or your STP cables. The only difference is how they shield the different cable. Like this one's shielded, this one's unshielded. We'll get a little bit more into that. Fiber optics, pull out a strand of your hair and it's smaller than that, okay, in thickness. You think it's hard? I've actually got a piece of glass that stuck into me when I was doing a splicing one time. It took it a week and a half to come out. Something smaller in your hair sticks in there. You don't even feel it. But luckily it was down here and not in my elbow because that would have really hurt. Feeling that crunching all the time, right? And have shards of glass. In wireless, of course, there's no specific dimension where you can see the wireless connectivity. Define local access networks. This room is a local access network. Okay? Or local area network, I mean. It means that all these computers are interconnected with one switch. They can all talk together. Okay, that is really the element to the maximum that you want to. All these devices, end devices, are connected to one switch.
Is that like an intranet?
No. Intranet is on the server itself, and I'll explain that later. Okay. This is a local area network. Okay. A WAN connects to LANs. Well, if you're on campus, it's really a CAN, and if you're on the other side of the city, then it's a MAN, and if it's on your body, it's a PAN, and then now they have bands, which are 33 feet around you because that's Bluetooth area network. Or, I'm sorry, no, that's considered PAN now. 33 feet is considered PAN. BAN is on your body, so it's body area network. Yes.
So what would be considered if your cell phone can be turned into a Wi-Fi hotspot? Because that's more than 33 feet.
When you turn that specific on, then you're connecting to a WAN environment. Because we're actually, technically, you're connecting to that LAN in which your wireless device connects to, like your phone. But you're broadcasting a LAN, so those devices that connect to you would be a LAN. You're acting as an intermediary device such as a switch. But you're routing the traffic. And if you want to do that, turn it on. We'll all use your Wi-Fi. It will kill your data rates, okay? How do we define the internet? It's just a collection of WANs. MANs, CANs, PANs, BANs, LANs. That's what the internet is. It's just a global mesh of interconnected devices. Easiest way to put it. Hey. I didn't even read that. All right. Now, inside of Packet Tracer, you're going to see these different icons. So this is going to be a PowerPoint you're going to want to go back and look at. Whether you go back to the recording and then hit pause so you can look at this, or you go into the PowerPoints that I've already left you in D2L, bring this one up. These are going to be what you'll see. That'll be a router. That'll be a LAN switch. This will be a hub. The difference between a LAN switch and a hub is you have the arrows. If it's a single arrow or single line with two arrows on the ends of it, that's a hub. If you have four, that's a switch. Okay. Server actually looks like a server. Desktop looks like a desktop, and laptop looks like a laptop. Those are pretty self-explanatory, right? Firewall looks like a brick wall. You've probably seen that icon many times. IPv phone looks like that. Wireless access point is basically a brick with the wireless signal in it. Okay, wireless signal is that loop-de-loop type signal. LAN media will always be a straight line. WAN will always have a Z in it to signify the LAN. Wireless router, what do you think? It's a router with 2 antennas. Okay. Network protocols. We're going to talk a little bit about network protocols. All the network protocols are to allow you to easily communicate between end devices. All right? Like I said, if Christina doesn't talk German and I start speaking German, we're not going to have that set a standard, right? So the protocols would define that we're going to talk on IP. She talks an IP. We can translate and we can communicate. There are 4 different types of protocols that you really will be dealing with. You'll deal with HTTP, TCP, IP, and then Ethernet. Ethernet, not so much anymore. Used to, you would deal with it. You were on a FIDI ring or token rings. You would have tokens. But most of the stuff you're going to be dealing with is going to be on IP or web. Okay. Technology independent protocols. You're going to have wireless and all that other stuff that are going to be separate from what you normally would do, but you can connect them all into the converged network. TCP and IP, or TCP IP and OSI models. What's the difference between them? Anyone want to take a guess? Raise your hand. Come on. Okay, the types of layers. What types of layers are you referring to? Just the names of them? What about the difference between 7 and 4? TCP/IP only has 4 layers. OSI model has 7. Anyone know them off the top of your head? Please do not throw sausage piece away. Right? Physical, data link, network, transport, session, presentation, and application. Did I get all 7? Okay. Please do not throw sausage pizza away. If you do, I will come after you and give you a 0 because I like sausage pizza. All right. Benefits include to assist in the protocol design. It'll foster competition between the standards committees, but they all provide a common language. All right. Here's your TCP/IP model. Network access. This network access is really the physical and the data link of the OSI model. Okay. Internet is your network. Transport's transport. Application is session, presentation, and application of the OSI model. All right. All it does, the communication process is you have an application. You start it, comes down through the transport where it gets its IP address, goes out through the frames, comes down to the bits, sends it over. It comes back up from the bits to the packet, to the frame, to the data. All right. What did I just call those? What are those 4 areas? Bits, frames, packets, segments, and data. What are they? Anyone know? It's called a protocol data unit, or PDU. You will need to know that. Protocol data units. Bits are on layer 1. Frame is layer 2. Packet is layer 3. Segment is layer 4. And data are all 7 down to 5. Okay? 5, 6, 7. Speaking of, here they are. Bits, frames, packet, segment, data. Now, you see how it encapsulates it, right? My true email is going to be added data up at the top. It comes down into my transport layer, which is going to segment my data. After it segments it, it comes down, and it gets a header added to it, which is what we call the IP header, right? That's where your IP address gets stacked on here. It says, I'm going to this IP address. Then it comes down to the frame. The frame has a header and a trailer. This is screwed up. But the frame header says, here's the MAC address of where I need to go. That gets all converted into bits. Bit sends it across the network. What happens is when a packet reaches that next device, whether it be a switch, whether it be a router, it comes up to that layer. If it's a router, it goes up to layer 3, unencapsulates it, finds it, re-encapsulates it, and sends it on. Okay? If it gets to a switch, it looks, am I the destination? Find what port I need to go out to that destination. Why? Because on a switch, your layer 2, you see the MAC addresses of those computers that you're involved in. Does that make sense now? Each computer, when it sends it out physically, has its MAC address. No NIC in the world has the same MAC address, unless you spoof it. Okay? So, an IP address will take it to that switch. That switch then sees, oh, it needs to go to this MAC address. That MAC address then sends it to that computer. Does that make sense? And then that computer can take it all the way back up to get that email. So when you're reading email headers, when you get into forensics, and you start, when it is first sent out, it gets that MAC address and translates it up to the IP address, puts it on that email up here with that data. That's where that email header comes into play. So when you're looking at the email header, you're actually looking right here. You'll see the email, but you'll see that header information. So as many times as it gets hit, it keeps adding data to that header so you can see where that trail of information went. Does that make sense now? How many of y'all have had forensics or tried forensics? Okay. Y'all remember this program, right? Y'all remember this assignment, what I'm talking about. But that's exactly what it's about. Now you can start putting 2 to 2 together and see the whole picture. That's how I like to teach in my classes for those that have never had me before. I like to give you that whole picture and see where these pieces of the puzzle fit. Because it makes it a lot easier for you, doesn't it? When you can tie it to another class that you've had information in. Example, user data. I get down to my segment. The transmission control protocol is on the what layer? If I'm segmenting, I'm on what layer? Transport. Transmission control, transport, right? Then I come down to the IP packet, right? What is this? IPs come in packets. Well, I'm tacking on my information, right? So an IP would be on what layer? Network layer. If I have an Ethernet frame, this is what Ethernet. Your MAC address is called a Ethernet address because it's your NIC address, right? So tack it on and tack some tailored information on its Ethernet frame. So where's my frame at? Data link layer. Does that make sense now? Seeing some heads, seeing some heads. Top. Yes. When it first hits into your NIC, it's all in bits. We'll have all this information. By the time, and when you get into Wireshark, and I'll show you, when we start talking about specific areas, I'm going to bring up Wireshark and I'll show you a frame that will show you the Ethernet area. We'll show you the IP area, and so you can see it how it's coming back up. And it's also going to teach you Wireshark, so that when you're in penetration class, or if you're in forensics class, you're going to pick up on this. It'll be a lot easier for you because you've actually seen it and see how it applies. Here's the OSI model. Please do not throw sausage pizza away. Someone told me one time, please do not throw spaghetti pizza away. I'm like, what? It's sausage. That's the only S that I know her. They go, well, what about salami pizza? I said, well, if that's your thing, you know. Here's the difference between the two models. Like I said, physical and data link are on your network access layer. Network is your internet. Network. Pretty simple to memorize, right? Transport is pretty simple because it's the same name. And everything else is an application layer, where you get application from. All right? Physical layer, what does it do? It gives you the timing and the communication. So when I'm going back to talking to Christina, it says, I'm going to talk at 60 beats a minute, and here's my traffic. Okay? That's what physical does. It gives you your bits, it gives you the timing and the synchronization of how I'm sending the data. Data link is that physical address of that NIC that I was talking about. Network, it's going to give you the logical IP address. Transport, it gives me what port am I using? Am I port 80, port 192, port 25, port 21? What type of traffic am I doing? And the upper layers are just the encoding of that data. Pretty simple. Now that I explained it, right? So if I give you a quiz on this next week, what are you going to do? Flip out?
Scramble.
All right, addressing the protocol data units. If I'm in yellow, what protocol data unit am I at? Device address. So what layer am I on? Layer 2. The physical device. Okay? These are IPs are all logical. Is there any questions on that brief summary? Does it make sense, though? That's what I'm trying to get across to you. I want to make sure that you understand the material and the concepts. Yes, sir.
Like you say, looking at Wireshark, when we go and we see like the time to live,
Uh-huh.
and the frame, all that information is what you're talking about.
Yes, I'll show you how it happens.
When you answer the question, you just know it, but I'm seeing how you relate that into actually the model.
Right. I want to show you. We'll take that OSI model because over the next few chapters we're going to break it down. Here's what the physical layer does. Here we're going to go through all 7 layers from here on out. Okay, of the OSI model will be covered in I think the last 7 of the networking area. Okay, and as we go through each and talk about each one of them, I'm going to bring up Wireshark and show you where in Wireshark you're going to look for the application data. Where are you going to look for the session information? Where are you going to look for the frame information? So that when you start looking at it in forensics, you're like, oh yeah, he says we need to find the MAC address. Well, I know where that's at. Then it arrived at this physical computer, and you can say without a doubt that that physical computer received it. If it's in logical, does that mean that time to live ended? No. Time to live. You brought up a good point. TTLs. Each device, from the originating device to the end device, each time it touches the device, it takes off 1 off the time to live. When we start getting into metrics, when we get into routing protocols, in the second half of the, starting with when we get into the book, EIGRP, OSPF, RIP, RIP2, IGRP, they all have metrics associated with them. All these metrics there's distance vectors depending on the distance, and that's how it takes it off. But they also all have time to live. So you see that TTL when you do a ping or a trace route, it says how many hops it took and how long it took and how many, typically a packet will last up to 30 hops. That means 30 devices between you and where it finished at. That's how long it took to get there.
Does that time to live have anything to do with whenever you're not getting connectivity and it says the connection's timed out?
The connection's timed out, that means it couldn't figure out where to go. That's all it means, is when it gets to a router or device that says, I'm not going to send your information on. Or it's not, because of ICMP, it's not going to tell you what it is. ICMP, Internet Control Message Protocol, that is what allows you to be able to ping. If you ever get traffic that says destination host unreachable, they either have ICMP turned off or you have a wrong IP address, one of the two. All right? So, I could care less about that. Let's talk a bit about Packet Tracer. I'm going to get you started on it. And then this is our first activity, right? You're going to have 2 different parts to Packet Tracer. You're going to have instructions, and then you're going to have your view over here, right? What this instruction area does is it's going to tell you specifically what you need to do to get 100 on this. And I'll show you where I'm looking for different things and what you're not going to be able to see when we get to the final here in a minute. Okay? They're really nice. They've already given you all the IP addresses and everything that you need for this network. Pretty simple. The first 5 or 6 of these are really basic. They're just trying to get you to understand how to configure different devices and how to use point-to-point connections and how you connect things. Okay? So, if anyone does not get 100 on the first 8 of these, you might want to think about dropping. Okay? And I'm not trying to say that it just means that you may not get the concept at this point. I mean, they're pretty basic stuff. I know.
I was just going to say, I wish they had this in routing like 2 or 3 years ago.
Well, it's there. Didn't have me. All right. What we're going to talk about first, the logical workspace. When we first open it up, you're in a logical environment, okay? Here's the logical workspace. It gives you all your computers, gets a switch, a couple routers, server, right? Pretty basic stuff. We're going to talk a little bit about symbols. We did that in the lecture, right? What is this? What is this? What is that? What are these? It's a desktop, PC, okay? You are going to see this. You're going to get sick of this particular image, all right? Trust me. You're going to have this for the first 11. Now, before I get into this, and here's our instructions right here for task 2. We're going to connect different devices, and I'll go over the different things with. You can go over and say, okay, here's what is connected here, here. I'll let you do all that on your own time. First, couple things you need to know. Down here in the bottom left, I know y'all might not be able to see that, but if you have it up on your screen, the bottom left, we have routers, switches, and as you go over, it tells you what's there, and connections. Let me blow this up a little bit. Now, if I click on routers, all these are different routers that I can use that are already pre-configured with exactly what type of modules they have. So if I tell you to add a 2811 router, you can just click on this, click on it, and paste it. That easy. Okay. Now, I'm not going to do that because this is an actual one that you're going to be graded on. But you see how I've got the X there? I want to go back to my hand so I can grab things. What we're going to do is we're going to do over connectivity. We have different types of cable. Okay. We have automatically choose, which if you use that, be very careful when you get on the WANs because you're going to have DCEs and DTEs. We'll get to that a little bit later on. You're going to have console cable, which you won't use. Copper straight through, copper crossover. You won't use fiber. You won't use a phone. You see the difference between the DCE cable? It has a clock on it. C stands for clock. When I have this in connected to a router, I must, in that configuration on that interface, give it a clock rate. Okay? We'll talk more about that as it comes along. But anyway, here's all the... And then if you have an octa-line, which we're not going to get into. Okay? So for this exercise, I'm supposed to connect Eagle server to the router 1 ISP. We're going to use the auto connect. So let's connect this one. Boom, connected. All I did was click right down here on the auto connect, which is down here in the thing. And all I have to do is connect it from here to here. This is what I was talking about with the rollover. It tells me what ports have been connected. All right. Brief summary tells me the IP addresses, gives me the MAC addresses, gives me everything I need right there. So I don't have to go in there and go show me run and bring me the whole running configuration, but it's right there. So for this one, I need to connect from here to there. Now notice I have an orange light here. What that means is that that line is administratively down at the moment. It'll turn green, but notice it says up here, when you have all greens, you're good. If you have an amber, that means it's either auto-negotiating still, or the line is down. Or if you have reds, the line is completely down. There is no connectivity. That means that port on one side or the other is completely down. All right? Now notice it went green, right? Now on this packet tracer, you see down here where it says completion 100%. That means I have completed everything I need to do for this first packet tracer. I can save it, upload it, and get 100 for my class. That's your first packet tracer. That was your first assignment. Connecting those two. I just did it for you. I'm going to get to that here in just a second. How do you save it is a good question. File, save as. Save as where you're going to save it at, okay? Save it to your desktop. I usually tell everyone to create a folder that says Cisco Packet Tracers. Just drop them in there and upload it, okay? And I'll show you here in a minute what your final is going to look like. All right? Now, on this activity sheet, one thing you can do is you can go and say, check results. I can go to assessment options or assessment items. It'll tell me everything I've got to do to get 100 on this assignment. Isn't that nice? However, you're not going to get that on your final. Okay? So try not to use this. Try to think logically how to get things done. I'm here to help you. You can email me. You can call me. And I'll be there to help you, okay? And that's what this is about. So I'm going to close this out now that we've completed our packet tracer, right? And we saved it. We've uploaded it. Is there any questions on how you upload? Y'all have all uploaded something to D2L, right? Drag and drop or click the upload and upload something. Once you do it, I usually like to grade the day after something is due or the Monday after something is due. Okay? If I see it beforehand, I do not like my my D2L to fill up with all these Dropbox and threads and discussion boards and all this stuff. So I like, when I don't have anything else to do, I'll go and look at them, all right? So, you thought that was pretty easy, right? Or pretty difficult? What'd y'all think? Y'all like Packet Tracer? Pretty simple. Now, just for the fun of it, oh, I'm sorry. That's not the right one. That's the midterm. Let's see here. Where did I put it? I may have to show y'all later. That's the same area I was in. Yeah, I'll have to show it to you later. I don't have it on this thumb drive.